All right, here we are at our 7.17 notes. Now we're kind of just looking at marginal distribution and joint probability as well. So to find out these items, we are on the you try it with the major and medical field. As you guys can see, we have some juniors, some seniors, some of those going into the medical field and others not, filled in with some of the data. Now, the totals are pretty much just as you would expect. So you would just take 124 plus 219, add those items together. And for the total juniors, there are 343 of those. Then for the senior class, just normal seniors, we have 101 going in the medical field, 236 not, giving you a grand total of 337. Okay. Now, again, those are the total juniors, total seniors. Now you can figure out how many are going in the medical field, yes, and no as well. So you're essentially, guys, you're just adding. So 225 are going in the medical field. And then 219 plus our 236 would give us 455. And then for the total, those two values should match. So if I take 225 and add 455, I should get 680. And lo and behold, if I add these guys as well, you would also get 680. So it's good to see that they all match. Okay, so that's not too bad, just figuring out the totals, right? Now we're going to be looking at the marginal distribution. Now, marginal, think of the word margin, and margin is pretty much all the items collected together, okay? So, for example, we have juniors, right? Whether they're going in the medical field or not, it doesn't really matter. There's just 343 of them. Now, for the marginal distribution or marginal probability for juniors, it would be 343 divided by the total. So in this case, there's 680 students in total. And so when we figure that value out, it is 343 divided by 680. It comes out to be about 50%, so 0.5. Now for the seniors, we have 337 of them divided by 680. So again, 337 of those seniors out of 680. It comes to be also like 0.4955. So essentially it's about 0.5 as well. Okay, but that's how you find the marginal distributions. So you just take the margin and then divide it by the total. So margin divided by the total. Okay. And then same thing here, you'd have for those going in the medical field, 225 are out of the total 680. We don't really care if they're juniors or seniors. We're just saying, hey, how many are going in the medical field? And so 225 divided by the 680, we end up with the value of about 33%. So 0.33 or 33%. And then those not going in is 455 out of 680. So 455 divided by 680 comes out to be about 67%. So about 67%. Okay. And then again, if you were to add these values, they should total 1. And likewise, if you add these values, it should total 1. All right. So that is marginal distribution, because again, you're really just using the margins to help you out, and then you divide it by the total. Now we're going to talk about joint probability. Now, joint probability is where you have to factor in each individual item, what like junior and medical field or junior not going in the medical field versus the total. So we'll go ahead and switch up colors. We'll go ahead and go with green. So of the juniors, we know that there are 124 students. Out of the total in this group being sampled, 680. And so we can then figure out what is this joint probability. So 124 divided by 680 comes out to be about 18%, so 0.18 rounding. For seniors going into the medical field, you have 101 of them out of 680. So 101 divided by 680. And that comes out to be about 0.15. And then for those not going into the medical field, well, there are 219 juniors not going into the medical field. So 219. Essentially, guys, you're just dividing each item by the total. So 680. And that's about 0.32. And then 236 over 680. We end up with about 35%. Now, noticing too, our values, like if I were to take this 0.18 and this 0.15, I get that marginal distribution, right? Or 0.32 and 0.35, I get 0.67. And that should happen, okay? So again, that's joint probability, where you're taking the two factors, like yes, they're going in the medical field, and yes, they're a junior, to then figure out what is that compared with the total. So that's why it's called joint. Now, what we want to do is the last item is we're just going to find out what is a conditional probability. Now, a conditional probability is like, hey, I want to know. We'll go with purple just to really change up colors for everything because I don't want to erase anything. Let's say, for example, I know the fact that this person is a junior, okay? So I know that they are a junior. What is the probability that they go into medicine given they are a junior? So what is the probability? I want you to pause, think about what is the probability that they go into medicine given that they are a junior? All right, let's go ahead and see it. So we know the fact that they're a junior, like there's no refuting it. They are a junior. So there are a total now of 343 juniors. So this now becomes the new total. This is what we call a conditional probability with the table. So there are a total of 343. And 124 of those juniors wanted to go into the medical field. So 124 wanted to do that. And so as a result, we would then just divide these two values. And we see that there is about a 36% chance that they, given that they're a junior, are going to go into the medical field. All right. I'm going to go ahead and give you another one. What is the probability that they go into the medical field, or actually we'll change it up, that they don't go in the medical field? Oh man, I keep messing, sorry. That was what I was hoping. Probability that they, that was supposed to be my given, I was thinking. Probability that they are a senior given that they don't go into the medical field. So this is my question. What is the probability that they are a senior, given that you know that they don't go into the medical field? Go ahead and give that one a shot. All right, so you know for the fact that they are not going in the medical field, and that is the total 455. So there are a total of 455 of these not going in the medical field. What is the probability that they are a senior? Well, there are 236 of those not going in the medical field. And then as a result, we would then just divide those values. And so when we do that, we get about 52%. So given that they're not going in the medical field, we can find the probability that they are a senior, which is 52%. Okay, so again, this is what we call conditional probability. So really fast recap. Here's our table. We had to fill in values like the totals for the marginal distribution or your margins. So essentially just add and you get your totals. We got the total right here. And then we were able to find out what is our marginal distribution, those percentages. So we just took the 343 divided by the total, got that, and so on. We really just did that for all the margins in the blue. Then we transitioned into, well, what is the joint probability? So given that they're a junior, or the fact that they're a junior and said yes to the medical field, there were 124 of them out of the total 680 students, and so on and so forth for all the other different fields. And again, that's a joint probability. And then finally, the conditional probability. So given that a certain scenario is happening, like you know it's happening, that's going to change your total. What is the probability that you randomly pick a student from this field? So we use the example, what is the probability that they go into medicine given that they're a junior? Well, we know that they are a junior. There are 343 of them. And 124 of those guys said yes to the medical field. And then the next one, given that you know that they're not going into the medical field, what's the probability that they were a senior? Well, we knew that they were not going in was 455 were not going into the medical field. And there were 236 seniors. So that is what we call conditional probability, because there's that condition added there. All right, go ahead. Feel free to pause the video if you have any questions at all. I just wanted you guys to see these types so that you have some exposure to marginal distributions, joint probabilities, conditional probabilities with a table.